Okay, let's introduce integration. Now, first thing I want to just show you is that this is the integration sign, and it has to be accompanied with something at the back, dx, because this is telling me what I'm going to actually integrate. So now integration is the opposite of differentiation. So here, instead of taking one away from the power, I'm going to add one onto the power. So the opposite of differentiation. With differentiation, you would times by the old power, but with integration, you divide by the new power. And so this one here becomes 2x, and I add 1 to the power, and I divide by the new power. So you can see that these are going to cancel out. And this, which is actually 1x to the power of 0, actually becomes x to the power of 1, or x, or 1x. Now that looks great. So what happens if I was to differentiate that? I should get back to the beginning. So that's what I'm going to do here. I'm going to differentiate this. So I'm going to do x to the power of 4. I'm going to take 1 away to give me x to the power of 3. The 4 then divides by the 4, so they cancel out. So that gets back there. Plus I'm going to do x to the power of only 1, because I'm taking 1 away. I'm going to do 2 times 2, which gives me 4, divided by the 2 gives me 2x. And 1 comes to the front, and 0. So this looks fine. This is going to be x cubed plus 2x plus 1. It's right back at the beginning. But what happens if we were to take this and add something on at the end? Like plus 3. Now when we differentiate that, that 3 will just disappear. So in other words, what we're saying is we can have this expression, but we can have something at the back, a constant number plus c. So when we integrate and we do something called we're doing differentiation without limits. We normally have limits here, but we'll come to that later. We've always got to have an add c at the end. So let's do another one. Let's do another one just very, very quickly. X squared plus x plus 3, and I'll put a dx there to indicate that I'm actually integrating. This becomes x to the power of 3, and divide by the new power, plus the power is 1 here, so the new power becomes 2. I divide by 2, plus 3x. And now I'm just going to put a plus c on the end. So when I differentiate this, it becomes 3x squared divided by 3, 2x to the power of 1 divided by 2, x, 3x to the power of 0, and the c just disappears. So I'm back to where I started.